Alright, so this is just a quick review of some of the ideas we've been talking about in class. So I'm going to try to kind of walk through from the beginning to end, starting with our definition at the definite integral, how to use that to approximate the area under a curve, how to then do that on the computer, how to find the area between two curves, the volume of a solid of known cross-section, and finally the center of mass. So to begin with the definite integral, remember that this problem was all about figuring out the area under a curve between 2 points, some point A and some point B. And we know this curve is defined by some kind of a function here. So our approach was to use rectangles, and we made a couple of assumptions about these rectangles. We said that they were equal widths for us, and we called those widths delta x. Depending on how many rectangles we had, that determined what delta x was, and we said that delta x was going to be whatever the total length of the interval was, b minus a, over however many rectangles there were. And so the area of each rectangle has the same width involved in it, right? We've got this is the width. So then we have to find the height, and we said for our purposes we'll find the heights over here at these points on the right end point of these intervals. And those are determined by this function, and at these points, we have to plug in these x coordinates, these 4 of them, to get the heights. Well, this first one, we start at A and we go over one width. So that x coordinate is A plus delta x. And we have to take that and evaluate what we get at the function. That's the height of the first one, and it has width delta x. That's area 1. Okay, that's this guy, A1. A2? Well, same width, delta x, same width here. But now I'm going over 2 delta x's, so f of a plus 2 delta x, and that is A2. Similarly for 3, the thing that changes is just where I'm finding the height of this rectangle. Now it's right here, okay, at 3 delta x's, and so on and so on, for however many subdivisions we determine. So what we get is this: every rectangle has a width of delta x, so we have delta x that we can factor that out, and we've just then got to add all of these heights together, which we'll do using our summation notation. We said we'll start from 1, we'll go to n, and it'll be f of a plus I times delta x. And there's our approximation formula. So the next thing that we want to do is maybe actually use it. So let's say that we have this curve, f of x equals x squared plus 1. And I'll say that I have 4 rectangles, and we'll go from 0 to 2. Okay? So let's take a look at that. That curve, x squared plus 1, is going to look something like this. And we'll say here is 2, this is 0. So again, this is x squared plus 1. And we want 4 rectangles here. 2, 3, 4. And we're going to build them like this. Alright, so first our delta x is going to be the width, which is 2, over 4 rectangles. So delta x is 1/2. And then we said we were going to find, we've got 4 rectangles here, So let's 3 and 4. This is the width, which is 1/2, times the height, which we find here at 0 plus 1 width at 1/2. So times whatever f of 1/2 is. Area 2 at f of 1 now, because we go over 1/2 plus 1/2 is 1. Area 3, 1/2 times f of 3/2, and area 4 would be 1/2 times f of 2. So then I just have to go ahead and actually plug this stuff in, but really I would rather use the computer to do that. So let's go ahead and quickly see how we can do this in Python. So let's start by defining and plotting my function, which I said was going to be x squared plus 1, and we're interested in this where x is between 0 and 2. So we'll quick plot these and take a look at that region. Okay, here it is. So then we had a width, which was 1/2. So then we have our heights, which are going to be f of I for I. Well, actually, what we want to do is we want to do f of 0, which is a, plus I times the width for I in range. This will be 1 to 4. This will give us the numbers 1 to 4, and those are the heights that we want, and we can see that here are heights. And so then what we need to do is we need to add all of these together, multiply them by the widths, and we'll get our area approximation. So we can say that the total area will equal the sum of the heights times the width. And so we get the total area is 5.75. Okay? So there's our approximation using 4 rectangles under the curve.